Hey, so this is day 32 of doing Leetcode daily until I get a job. So we are continuing with the questions. Just a second, let me fix this to this side. Okay, yeah, this is cool now. Okay, because it was covering some content. Fine, let me make it a little smaller. Fine. So, yeah, let's continue with the questions. So we have this first missing positive here. Fine. Okay, all good. So first missing positive. Given an unsorted integer array nums, return the smallest positive integer that is not present in nums. You must implement an algorithm that runs in own time and uses own auxiliary space. Fine, so do not have to, we cannot use any extra space. See, if extra space was given, that question will have been so easy. Or n time limit is not given, then also it has been so easy, because we will just sort it and we'll check that from starting from 1 which element is not there in it. Whichever is not there, like we will check the smallest element of the array after sorting it. Okay, whatever it is, we will just return -1 of it. But if the number is 1, then we will go to next and then again check the same condition. But in that case, we have to sort the array and it will take o n log n time, but we have to do it in of n time. So we need to find something through which we can do it in a single iteration. Okay, so what can we think of it? There is a missing number. There is a first missing number which is positive. See, if uh, so basically it is a n-sized array. Fine, so we have a n-size array. Fine, and it has some number, maybe positive, maybe negative. We have to find first missing positive. Fine, so if it's n-sized, and let's just assume, let's try to find the range of the missing number. What can it be? See, if the number is starting from 1, then we need to go for something, like we need to search for something. But if the smallest positive is not 1 in the array, we are sure that the answer will be 1. So we can conclude about this question from the given condition is that the missing number must lie between 1, 2 and minus n plus 1, where n is the size of the array. Why I am saying this, that the number will be only from this range? There can be any numbers in the array, right? I'm saying this because let's just say the list is this. Ignore the -7s, -0, ignore all these. Just pay attention to the positive numbers. Okay. Let's just say that it was the array size is 5. So what I'm saying is missing number must be between 1 to 6. So we will check for 1, right? Yeah, 1 is there, 2 is there, 3 is missing. So 3 will be the answer. What if the array was 1, 2, 3, 4, 5? In this case also the missing will be 6. Yeah, in the range. What if our number is something else, 6, 7, 8, 9, 10, or anything, then our number is simply 1. We will start searching from this side, go to this side, and can find the solution, right? Missing number will always be from this range. We can find any condition here, it will satisfy, right? Because if it doesn't contain any of the first n numbers, where n is the size of the array, then the condition will not be satisfied. Means missing positive will be from these numbers only. We have to check just these n plus 1 numbers, and That's all we need to do. That's all we need to check. Okay, so what we can do now is we can take the size 1 to 6. So these are the possible 6 numbers which we need to check. So our search space has reduced a lot. Firstly, we need to check for we don't know how many positive numbers, but now our search space is just reduced to these n plus 1 numbers, 1 to n plus 1. But still, for doing this, we need to search in the array, correct? And that will be not O n time, obviously, right? We need to every time we need to search in the array. Let's say we search for 1. If 1 is there, that's just the best case. That's we just found that 1 is not there. We just iterate the array once and we found that 1 is not there, 1 is the answer. That's the best case. What's the worst case is 6. Okay, we will search for 1, and what's the worst case? We will go to the last of the array, big size array, n. Again we will search for 2, again we will go to n. Again search for 3, again we will go to n. So this way it will be a lot more time than we expect it to be. But with the same uh, information, we can do something else. We know that these numbers should be there. Okay, if all the first n numbers are in the array, then our answer is obviously what? N plus 1, right? Okay, our answer is n plus 1. We are checking from, we will check the array for 1 to n. If we find all of them, then our answer is n plus 1. And while finding, if we do not find any one of them, then that is the answer, correct? Our conditions are understandable, fine. Now this step is done. What's the next step is, if we have to find these only, what we will consider that everything 1 to n exists. Okay, now we will just put these numbers in their respective positions. We will try to put 1 at the first index. We will try to put 2 at the second index. We will try to put 3 at the third index. Means we will try to put nums I at nums I minus 1 index. Means if the value is x, we will put it at x minus 1 index. This is the index value. Okay, if 2 is the value, then we will put it at first index. Sorry, 1 is the value, then we will put it as 0th index. 2 is the value, we will put it at first index. This is how we need to do. Okay, we have put them all. If we find them, we will put it. If we do not find, we will just move forward and leave it as it is. Now we will start from the first index of the array and start seeing which value is not equal to its index plus 1. Whichever value is the first value which is not equal to its index plus 1, this is our answer. For example, let's just say that 5 2 1 4, this is our array. Now put 5 at 5 plus 1 index. Is it possible? No, 5 will be here only. Now 2, put 2 at first index. It is already there, fine, it will be staying here. Put 1 at 0th index, so we will swap those two. Then what will it result? 1 2 5. Put 4 at third index, it's already there, right? So whatever we could have done to put the numbers in their respective places, we have done it. Now start from this index and check if the value is equal to its index value plus 1. Is 1 is equal to 0 plus 1, so its index is 0, its index is 1 and 2 and 3. This is fine because 0 plus 1 is equal to 1, 1 plus 1 is equal to 2. This is also fine, but this is not fine. 2 plus 1 is equal to 3. The value should have been 3, but it is 5. So we will return what? index plus 1. We will return that this is the answer to this question. 3 must have been there. So 3 is our answer. 3 is the first missing positive. This is how we can do this without using any extra space within linear time. So let's start writing the code of it. So let's firstly define the size as nums dot size. Fine. Now let's take I as the iterator, and while I is less than n, we will go forward. We will do what is now we have to first check a condition. What if the number is already in its right position? Then we don't have to do anything. Okay, if means the number is already in its right position, means if nums I is already equal to nums I minus 1. See how this happens is that nums 1 is always equal to, let's say nums 1 is already 1. 1 should have been at the first index, right? Nums 0, sorry, nums 0 is 1 already. So nums 0 is nums of 1 minus 1, nums 0. So it will, so we have to find the condition for swapping. So we'll do this. If this is not equal, then we will swap it. Then we will swap these two values. Fine. Try to understand this, that nums I is the value currently at some index. Let's say 1 is at right index, right? It is at its correct position already. We don't have to swap it anywhere. So we will check how is its right position. We will see that nums I means nums 0, 1 is already equal to where it should be. Where it should be. Nums I minus 1. Nums I is already 1. 1 minus 0, 0. So nums 0 equal to nums 0. This condition is true. So it's already at right position. But we have to swap when it is at its wrong position. Okay. So this is the condition. Second thing, if we see this 5, in the case of 5 we were not doing anything. Why we were not doing anything? Because 5 violates the indexing of it, means it goes out of bounds of this array. Array is of size 4 and we are trying to put it at index 5. Is it possible? No, it is not. So we have to check before this condition. We will check what is that nums I should be less or equal to n, because we are only checking the numbers from 1 to n. This is the only possible range for the missing number. So that's the range we are considering. Also, one more thing is that we cannot even do if we want to search for the numbers, because the array size is n. We can put the number on an index that is permitted by this array, which is from 0 to n minus 1. We cannot put any number more than n at its right index, right? So we cannot put 5 anywhere because there are only 4 indexes. And also for handling the negative numbers, nums I should be greater than 0 also. We are not considering 0 because we have to check the first missing positive. So 0 is excluded from this. Only natural numbers are considered. Fine. And third condition is this. If all these conditions are true, that means we need to swap the number. Swap which numbers? Nums I with nums of nums I minus 1. Okay, we will swap these numbers, and if nothing is there, if we have swapped it, we will just do I plus plus. Okay, after swapping we will just do I plus plus. If we do not have to swap, we will just miss it and go forward with whatever value we have next. Okay, and then we will start iterating the array from its very first index to the last index, and we'll check here that if nums I is not equal to I plus 1, value is not equal to its index plus 1, then we will just return I plus 1. Okay, and if everyone is at right index, then n plus 1 is the first missing positive. So this should work fine. Let's see. Yeah, it's working fine. Okay, this is working fine, but one more thing can be done here, which is that while after swapping, we can also increment I, so that we don't have to check the same thing again. Right, I'm getting at what I'm saying. No, it will actually do some loss here, but that's fine. We are not going into much details. That's fine, we did it. Let's move to the next question. Perfect, 100% it is. Fine. Now next question is wildcard matching. Let's go with this one. This one is also hard. Fine. So it's kind of similar to what we have done in regular expression matching, but what's different here is that firstly dot ki jagah we have a question mark. That doesn't make any difference. That's fine. But the star makes all the difference. Okay. In the regular expression matching, star meant that star will basically never be alone. Okay, it will be a successor of a character, and that character can be multiplied by any value, means can occur any number of time, possibly 0 if a star is after it. But here star can occur alone, and it basically means any sequence of character including the empty sequence. It can make empty space also, and it can make any possible sequence that we need, anything. Okay, so like this, if we have a AA and we have to match it with another string, and we have only a star here, star can make anything, so it will obviously match with it. If it is AA and it is only A, then it's not matching, right? And it is CB, this question mark will match with C because it will convert itself to C. Whatever we want, we can convert it to. But B will not match with it, so it is false. So this is how we need to done. And again, once again, I'm going to say the same thing, that whatever question, if it involves string matching, then we've got the DP. We have obviously got some other approaches too, but DP being the common approach possible there. And yeah, we can also do this by two pointers. That can also be the case that one pointer is here, one pointer is here, and whenever the characters are equal, or we encounter a question mark, then we will just move both the pointers, right? Otherwise, we can do what is, we will save the star position, and we will save that position where the star occur in S also. Okay, then we will search, see if it's fine, the string is matching, then okay. If it's not, we will backtrack and have a different meaning of that star. Correct. So that's how we will be doing in case of two pointers, but we'll be doing it, let's do it by DP approach, as we have already done it, and it's pretty simple. There's some differences that we will be looking at it in the code only, and you will see it will be as dot size, and m will be equal to p dot size. Now let's make a DP, 2D DP. We know why we are making a 2D DP, because it will be a 2D table. Two strings are being searched, so one string represent row side, one string represent column side. So DP is its name, and plus one size, and again a vector pool, and m plus one size, and all values false. Fine. Now dp00 is true. I think there is no need of explanation there, that dpij signifies what? P I J signifies what is that if the first string having length I, second string having length j, are they equal or not? If they are equal, this value will be true. If they are not, its value will be false. So first I characters and first j characters we are talking about. If they are equal, it's true. If not, it's false. This is what dpij signifies. Okay, so dp00 will be true because both the strings are empty, both the strings having zero length, then it's true. Otherwise, one more thing here, that let's just say that this is the first string, this is the second string. Up to here we have matched and it's all fine. Let's say this whole string is here, it still have characters. This is P and this is S, as discussed in the question. This is the uh, wild card characters are present in P. Okay, so this whole string is being matched only until there. After that there is nothing left in S, so what will we match? Then in that case, if these both strings has to be equal, then all the remaining characters should be star, no other character. Okay, if all the characters are star, what will happen is that these all star will constitutes themselves to empty string, and then they both will be the matching strings, right? Even the question mark should not be there because question mark needs a character, it cannot signify a empty space. Correct. So for this thing we will run a loop where if the first string is empty and second string has something, then that something needs to be all stars. If it's anything else, then it's false. So int I is equal to, we'll start from 1 and I less or equal to m, because n is already 0. So we will see what if p I minus 1 is equal to a star. If it's a star, then it's fine. Then dp0 I will be true. But if it's anything else apart from star, we'll just pick. Fine. No point checking further. Because if we encounter something, let's say first string is nothing, it's empty, and second string is all stars, then it's fine, the matching. If first string is empty and we encounter a star but a character in between, and then as many are stars, then they can never be equal because this character creates the problem. So if we encounter anything apart from star, then we will break out of it, and this is just for defining the boundaries, okay, of the 2D table of dp. Now let's do this for rest of the cases, and I will be starting from 1 less or equal to ni plus plus. This for loop will be starting from 1 to less or equal to n plus plus. Now first condition, if it's equal to this, sorry, okay, so if the characters are equal plus or or it's a question mark in the p string, then fine. If these characters are equal, what does this mean? This means that whatever the value was for j minus I minus 1 j minus 1, it's true. What does this thing basically means is, let me just explain it to you guys, that this means that dpij for I length of first string, j length of second string, Is it true or false? We need to find this. So it will be depending on if if their ith last characters are equal. So this is the first string, this is the second string. Here it is I and here it is j. Okay, so it is I minus 1 element, it is j minus 1 element, and it's starting from 0 and it's starting from 0. So these are the string we are considering. Are these equal? If they are equal, then it will be true. How we are doing this is that we are considering the last element. If si minus 1 equals to pj minus 1, or it's a question mark, then also it's the same thing. Then where the answer depends is, was the past string equal or not? Was the past string of both of these equal or not? And which is what basically? I minus 1 j minus 1 dp I minus 1 j minus 1, right now. So we have this answer saved for dp I minus 1 j minus 1 somewhere, and we will use this answer to find the answer for this if the characters are matching. Fine. But if the characters are not matching, then we have failed it, right? Otherwise, if it's a star, here comes the main condition. If it's a star, then what? See, what can happen here is, if there is a character here, okay, and here is a star, two things can happen now. Either this string is equal to this string j up to j, okay, up to j. We consider it as just empty. We consider it as empty, then what happens, that this string is equal to I minus 1th, okay. Either dpij, if we consider the star as empty, then what will happen? It will be I j minus 1, right ना, कि इसकी लेंथ तो आई रही, इसकी लेंथ तो पूरी हो गई है आई तक, क्योंकि आई पे ए है इसकी। क्या पता इसकी ये जो लेंथ है यहाँ तक क्या आई सुनी, या इसके पिछले कैरेक्टर तक बराबर हो, करेक्ट, या फिर आई माइनस 1 तक की लेंथ इसके जे के बराबर हो सकता है। और कोई भी केस हुआ तो डी बी आई जी ट्रू हो जाएगा। स्टार तो किसी में भी कन्वर्ट हो सकता है, इधर इट कैन कन्वर्ट इटसेल्फ इन अ कैरेक्टर or it can convert itself in a empty space. If in any of the cases it is true, then our answer for dpij will be true. Okay, this is really simple to understand. If you see if you just understand the length parameters of it, that we are checking it for I length of first string, j length of second string, and the character at the j minus 1th position is a star in p. Okay, now this star either can match the character, or it can be an empty space, or it can be any different character, right? So how we are doing this is I j minus 1 or I minus 1 j. What does this I minus 1 j and I j minus 1 signifies is that I j minus 1 signifies that complete length up to I of first string, and the length of the second string up to the last character before star, means we are considering star as a empty space. Are they equal? We will see. If they are equal, then this is true for it. If we do not consider it as empty space, we consider it as a character. Okay, we consider it as a character, let's say this or anything b, let's say, and this string is equal to the I minus 1 string of it. Maybe it can happen, right? That's the all choices we have. We like have to open up all our options in this case, okay, and see whichever is true will make our result true. We'll put a or between it. So that's how we can check it. These are the all conditions. If the character do not match and it's not a star, then it will be remaining false, which is obviously the already value filled in there, right? and we have to return what? We have to return dp n length of the first string and m length of the second string. What's the answer in that case? We just have to return this and we'll just submit it. I don't think anything is wrong there. Yeah, perfect. So like the similar question to regex, but a little bit tweak here, because it's a wildcard and we already know that wildcard and regular expression are two different things. The star means different, the star have a different meanings at both the places, so which make the questions different a little bit, but the concept is just the same. So this was the wildcard matching. We just did two hard questions in under 30 minutes. That is really nice. That is really nice. Fine. Now, okay, just a second. Perfect. Yeah. Okay. Next is what we have done the permutations. Yeah, I have done the permutations without the video because that was an easy question. I just need to do for maintaining my streak, and yeah, it's not of a big deal. We just have to find all the possible permutations of 1 2 3 here. 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2. So we will just make a 2D vector and we'll start calling the recursive functions by swapping two numbers. Basically we are doing all the possible cases and finding our answer, right? So similarly we can do the permutations too also, with it must have a little change in it, but it must be similar. Yeah, the change is only that they are duplicates in this array and there were no duplicates in permutation. So let's do this the same way. But one thing, there are duplicates here, so it will contain the it will possibly contain duplicate sets like 1 1 2, and changing the positions of these two 1 1 1 2 again will be there, right? So let's initially take a set. Okay, let's take a set of vector. Later we will convert it to vector of vector before returning. Okay, so let's just say it s. Fine, and we will call a function here which will take s for the array size, array, and the first index of it. Perfect. And let's just take array size also, nums dot size n. Fine. Now it will be a void function, right? Void solve. What are the things in here is case and a set will be here. Perfect. Vector of numbers will be here. Fine. The starting point will be there and the size will be there, index and the size. Okay, at any point if the I becomes equals to n, we just have to insert the modified array into our answer. So s dot insert nums, and we will just return. Fine. Apart from that, what we need to do is we will just start from, let's say j. We will start from I. J is less or equal to, not less or equal to less than n, and j plus 12. We will run this for loop similar to the permutations question. We are finding all the possibilities here and just saving them to answer. Okay, we will swap the two numbers which are what, nums j and nums I and nums j. We will swap these two numbers. We will call the function again with s nums next index, and next index basically next index will be idx plus 1 or I plus 1, yeah, idx plus 1 obviously, yeah. And we will backtrack again. We'll backtrack, that will be nums I and nums j will be again swapped. So I guess this is perfect, and this will give us a set, but we need to return a vector. So we'll make a vector and answer, and it will contain s dot begin to s dot end, and we will just return answer. Let's see, it should be fine, I guess. Yeah, we just need to handle the duplicates here. That's all we need to do. And yeah, we just took a set instead of vector, and then did the job perfectly fine. So yeah, this was the one. Next is rotate the image. That's pretty easy question if you know this. Like, it's really easy one. See, we are basically doing what is that, converting it to this matrix 90-degree. Okay, rotating it 90-degree. So but basically it converts it into itself is that, how the processes can be done here. See, what's the transpose of this matrix? This transpose of this matrix is 147, 258, 369, right? And if you notice that it should be 147, but it is 741. So is it just reverse? Not actually. Because why? If we notice, it might seem reverse, but let's say this question 5 to 13 15. Transpose taking 5 to 13 15 will be a row, and the first row here is 15 13 to 5. It's not reverse, or is it? I don't think so. That's a reverse. 5 to 15 13. Reversing it will give us 15 13 to 5, 15 13 to 5. Yeah, it is always also reverse, but uh, you see, the concept here is that's replacing the swapping the column values with first column and the last column, second column, second last column, third column, third last column. It will basically give us a reversed value, but fine, we just have to swap these things. Like, we'll swap 15 with 5, 2 with 13, so it will give us this. Okay, and whatever left in the middle, if they are like odd number of columns, like in this case, we just swapped 1 and 7 for even in the middle. Let it be, right? So this is how this question can be done, and yeah, we can do this tomorrow. And how many questions remain here is just the two questions, 48 and 50. Otherwise, we have done all these questions. Okay, of the first page. After that, we'll start the second page. So 153 are totally done. That's nice. And we are done with the questions today. Rest will go for the rest of the questions tomorrow. So that's all.